All right, so today's lesson is all about transformations. So before we even start the mathematical idea of transformations, I want to focus on this prefix trans. So think of some words where you've heard trans before, right? So you might think of some words like translate, or maybe the transcontinental railroad. Okay. Or you might think of the word transformers. So, and translate, if you translate something, you're changing it from one language to another, right? The transcontinental railroad goes across continents, or it changes from one continent to another. Think of the transformers, right? They change from machinery, cars, into robots, right? So this prefix trans means to change, okay? And in math, we use transformations to prove that two or more objects are congruent. Remember that congruent means that they're the exact same. So we're just going to start with two triangles that may or may not look congruent, right? But there's a way we can prove congruency. If you can get two objects, right, directly on top of each other, okay, and they appear to be the same exact shape, then they are congruent. We've proved they're congruent. So we're going to use some very specific motions to prove congruency. So my goal here is to get these two objects directly on top of each other and describe the mathematical process behind that. All right, so I'm actually going to start with it down here, okay? So my goal is to get triangle 1 on top of triangle 2. So the first thing I might do is I might slide this triangle to the right, and I might slide this triangle down, right, or the other triangle up in order to prove, or in order to line them up to prove congruency, okay? Now, the next thing that I would have to do is I would have to flip one of these triangles over this line. So I could flip this one left to right. I could flip this one right to left, right? And once I've done that, I have proved, right, they're on top of each other, I have proved that they are congruent. So we slid one over, right, and then we flipped another one. All right, let's add another piece in here. Okay, so let's say we've got this triangle looking like this. Okay, so you might think, okay, it's the same thing. Let's just slide this one over and then flip it, right? But as you can see, they're not directly matched up. They are not congruent. Okay, so let's look back over here. So maybe then we need a different transformation. So another thing we could potentially do, right, is we could turn, right, we could turn our shapes. Okay, now they look like they're in the same relative position. And then we could try to maybe flip one, right? So that didn't look like it did as much. So maybe let's try turning this one. And then let's maybe try sliding it over. And you notice something's still going on here, right? Okay, so let's try this. Let's turn this one. Now let's flip this one. And now let's slide it over. And hopefully, right, we can get those shapes on top of each other. So notice we are kind of doing 3 different motions there. We were sliding it. We were turning it. And then we tried flipping it. Now, there are technically more mathematical terms, mathematically appropriate terms for these 3 movements. So a slide, we actually call in math a translation. We're translating it. We're moving it across, right? The prefix trans, we said change. It also can mean across, right? If you translate something, you're moving it across. Like you're translating a language, you're moving it across from one language to another. Or the transcontinental railroad goes across continents, right? So slide is a translation. With that, we typically describe, right, left or right, up or down, and then we typically use an amount. And a lot of the times we're doing these transformations on graphs, so we might use units on a coordinate grid to describe the amount. Okay, a turn, right? A turn, a more mathematical word for turn is a rotation. And we talked a little bit about turns not too long ago. So to describe a turn, we can use clockwise or counterclockwise. And then an amount, we can use a number of degrees, right? So I might say turn it clockwise 90 degrees, or rotate it clockwise 90, rotate it counterclockwise 180, right? So rotation is the technical word for turn. And then flip. For flip, I want you to think of looking in a mirror. When you look in a mirror, you see your reflection. So a reflection, right? So a reflection, right? A mirror image is a flip, right? You're either flipping it left to right, or maybe you're flipping it top to bottom, bottom to top. And with a reflection, we typically use a line to describe what we're going to reflect it over. So if we're talking about a graph, we may reflect something over the X or the Y axis. If we're talking about, right, a specific shape, let's say I labeled these A, B, and C, right? So I might say reflected over line AB, which would be this way. Or I might say reflected over line CB, which would be this way. So that is a very, very basic introduction to transformations, slides, turns, flips, and their technical names, translations, rotations, reflections. And then notice that we're always describing, right, the amount and the direction of the specific transformation we are doing.